Hello, it's Keith from Kinvert, and in this video we are going to be going over how to find out if a graph of equations has x-axis symmetry. So let's take a look at these two equations that are being graphed here. The first one, the original, is this blue one, and what we want to know is if the orange one has symmetry across the x-axis. And if we look at this, we'll see that at this point, for example, it's just a little bit further down than -3, and this one's a little more than +3. And then we get over here, and this one's between 1 and 0. This one's between -1 and 0. So we can see that for each y value, it's just basically a mirror of each other. So for the blue one, they tend to be positive y values. So for the blue one, they are positive y values. And then for the orange one, they are negative y values. And the values tend to match each other. They are just opposites. So this one has x-axis symmetry. Let's look at another example and see if it has x-axis symmetry. So for the original one, I am going to graph it in green, and it's going to look like this. And then purple will be the other one, and it will be like this. So I want you to pause the video and think, is this symmetric across the x-axis? The green one and the purple one. The green's the original. Is the purple one a symmetric version of this across the x-axis? So go ahead and pause the video with the K button, and you're going to get the answer in 3, 2, 1. So in this case, yes, this one is also symmetric, okay? Because the positive y values are basically the same as the negative y values for any given x. Let's take a look at another example, and we'll start with kind of yellow, and we'll draw this one over here, and it goes like this. And then the other one we'll do in red, and it goes like this. All right, so are these two symmetric across the x-axis between the yellow one here and the red one here? Are these two symmetric? I want you to pause the video and come up with your answer, and here it comes in 3, 2, 1. And in this case, no, they are not symmetric. So you can see that here, when x is -8, this is around +1, and this is also around +1. So in this case, they are approximately symmetric, just where x lines up here, as well as where x lines up here, right? These y values seem to be the opposite. So this is at +2, and this is at -2 when x is at -10. But if we get over to here, let's take a look especially at this spot here. Okay? We can see that these values are not symmetric. Here, x is at -4, 5, -6 approximately. X is -6, but y is only -1. Where here, y is +2. So this is the reason that these two are not symmetric. Whenever you have an equation, for it to be symmetric, you have a negative y value or a positive y value for any given x value. So we should be able for this one to be symmetric. Like, let's look here. And remember, I hand drew these, so they won't be perfect. But here, when x is +5, y is +2. So for x is 5, x equals 5. And then we've got these two things for y. So the positive y is 2, and the negative y is also approximately 2. I drew this a little too far. It's maybe 2.5 or something like that. But hopefully you get the picture. I'm going to call that -2. I hand drew this, so this isn't perfect. It was intended to be symmetric. So this is Keith from Kinvert. We went over x-axis symmetry when we're graphing these out, how to know if they are symmetric across the x-axis. And the way that you know, A, you can kind of look at it and get an idea, but B, you want to know that for any given x value, the y values are the same but opposite sign. All right, hope this was helpful, and we will see you guys in the next one. Bye-bye.